Okay, question number 1. We have been given a graph. The question says the graph shows how the distance traveled by a vehicle changes with time. So we have a graph which is a distance time graph. In the y-axis we have the distance, and in the x-axis we have time over here. And secondly, there are 4 points on the graph: P, Q, R and S. These are maybe stops in distance. Maybe we are not labeling the graph, but maybe this is a 20 meters and this over here is 30 meters, something like that. Now we have been asked which row describes the speed of the vehicle in each section of the graph. Okay, let's check through the options then. First thing I can notice over here is that we have a slanting line over here which has a fixed slope. Now what a fixed slope means is that the line is not curved. It is not like this. This is not how the line looks. The line looks like this. This is a fixed slope, and a fixed slope means a fixed speed, because at a constant rate the distance is increasing. Therefore from P to Q we can say that the speed is constant. So checking through the options, we can say that C and D are already eliminated. Now let's think about Q to R. Over here, throughout this time Q to R, the speed is 0 because the distance is not changing between Q to R. So therefore the speed will be 0 over here, and in both options A and B, that is 0. Therefore A and B are still there, and C and D are instantly eliminated. They were already eliminated in the previous round. Now let's check between R and S. Now R and S has a very similar situation to P and Q. The only difference is the speed is less because the slope is less. So it is traveling less distance in more amount of time, but still the speed remains constant because over here we have a straight line, as you can see. So checking through the options, we can see that only in A that happens. So B is also wrong and A is correct. Question number 2. This is again a very conceptual question. A stone falls freely from top of a cliff. Okay, so we have a stone and a cliff. Air resistance is ignored. So the first thing that comes to my mind is that when air resistance is ignored, we always have a constant acceleration. Like that's what air resistance does. Air resistance provides an opposite force. So if I have a stone over here, earth over here like this, the stone is falling down due to gravity. It has a force on it acting on it due to gravity. Air resistance is providing an opposite force. So it is providing an opposite acceleration. When we don't have any air resistance, we have no opposite force. So the force on this stone will always be constant and acceleration will be constant. Now let's check what the question says. Which graph shows how the acceleration of the stone varies with time as it falls? Okay, so we have 4 acceleration time graphs. Okay, fine. So let's check through the options. Option A looks like this. A over here, T over here. Over here we can see that the acceleration is increasing. Y-axis is acceleration and acceleration is increasing with time. Therefore this is wrong because we clearly discussed that acceleration will stay constant because the force is constant on the stone, which is just the weight. So A is wrong. Option B looks like this. This again is wrong because the acceleration is decreasing. We don't care about the slope. We need it to be constant. So B is also wrong. Option C says, again option C is wrong because the acceleration is changing. Option D says, okay, option D seems like the correct one because the acceleration is remaining the same across all the time. So maybe this point we can mark as 9.8 meters per second square, and this is remaining constant throughout. Therefore option D is the correct one. Question number 3. A car travels along a horizontal road on a straight line. So we have a car that is traveling on a straight line, and we have been given a speed time graph over here. So this axis is time and this axis is speed, representing speed using V. Now we have to find the acceleration of the car. So there are 3 ways that perform the same exact calculation, get to the same exact value, but there are 3 ways of thinking about the calculation. Okay, so the first way is the slope, finding the slope. So the first way is finding the slope. Now finding the slope, what we do is we take this coordinate over here, we take the y value, so that's 30, minus we take this coordinate 20, and then we do 20 minus 0, change in y upon change in x, which will give us 10 by 20, which will give us 0.5 meters per second square. Now we already know that our answer is A, but there are more tricks though. Now there's a second way, that is directly using the formula, which is acceleration equals v minus u by t. V over here is the final velocity, u is the initial velocity, and t is the change in time. This again becomes the exact same thing, 20, and we again get meters per second square. Now there's one more way which is sort of more intuitive and the quickest way actually. It is to directly think about acceleration as being change in velocity upon change in time. And when you look at this graph, you will see that the velocity is only changing by 10 units over here, while the time is changing by 20 units over here. Therefore you can easily say 10 over 20, which is 0.5 meters per second square. Again, these are exactly the same calculations, just this one is way more intuitive, direct and quick. Now about the slope idea, there's one more thing which I'd like to focus on. It is this kind of staircase which has helped me a lot personally. So on the staircase over here you put acceleration, over here you put velocity represented by v, over here you put displacement or distance represented by d. If you have a graph for velocity time graph or a acceleration time graph or a distance time graph, if you want to go down, that is go from acceleration to velocity or velocity to distance, you can find the area under the graph. If you want to go up, you can just find the slope of the graph. And that's what we did. We went from velocity to acceleration, and here we found the slope. This is a staircase which I personally very much like, and you can use it too. Question number 4. So we have a random spaceship. So maybe it looks something like this. That's irrelevant very much. Okay, we have a random spaceship and it is coming down. So it enters, yes, it approaches Earth from deep space. Now near Earth, a force is experienced by the spaceship, and we have to tell what is that force that is causing the weight of the spaceship. What is the force? What applies the force? What is the type of force? So we know very well that weight is caused by gravitational force. So options C and D are instantly eliminated because only A and B contain gravitational force. Now the second thing we need to consider is that what is the property that resists change in speed and direction. The options we have are mass and volume. Now there's a very simple argument to make here. It is that mass has inertia. So over here mass is overall the relevant one because inertia tries to stop. So inertia is the property that tries to stop and resist change in speed and direction. And volume has nothing to do with inertia. So mass is our correct option. Therefore option A is correct. Question number 5. We have two diagrams over here. The first diagram shows an empty box. So we just have a random container, a box, which weighs 60 grams. So the mass of the empty box is 60 grams. Now the box is filled with liquid and the total mass then becomes 300. These are just variables over here. We have been given the density of the liquid. So rho liquid is 1.2 grams. Now the question is, what is the volume of the liquid in the box? Okay, so the first thing I can see is we can get to the mass of this liquid, because when the box was filled we had 300 grams and empty we had 60. So the mass of liquid equals 300 minus 60 equals 240 grams. Now we know we have 240 grams of liquid. We know the density is 1.2. We can put in the direct formula. We know that density is equal to mass by volume, which basically means this was the calculation, and therefore option B is correct. Question number 6. We have an object, we don't know the mass, we don't know actually anything about it, and it is traveling in a circular path with a constant speed. Now we have been given 4 statements and asked which one is correct. Okay, so let's check through all of them. Option A says it has changing kinetic energy. Now we know that is absolutely false, because we have a constant speed over here and we know Ke. Therefore, as long as the velocity or the speed stays the same, the kinetic energy will stay the same. Therefore, the kinetic energy is not changing for sure. Option B says it has changing momentum. This seems like a promising option because the direction of the object's velocity is changing. So right now it is in this direction. Maybe over here it was in this direction, and therefore the direction of momentum is changing. So momentum is actually changing. So B may be one of the correct options. I mean, there is only one correct option. Option C says it has constant velocity. This is absolutely wrong because the direction of the velocity is changing. We have a constant speed, we don't have a constant velocity. Option D says it is not accelerating. This again is wrong because actually the object is accelerating if you think about it. When the object is here, it is accelerating in this direction, and that is exactly the reason why the object is able to come here. Otherwise, it would have left in this direction. It would have left in this line if there was no acceleration like this. Because of that acceleration, the object comes here. So therefore option D is also wrong because there is an acceleration. Seems like option B is our only bet, and that is correct. There is a change in momentum throughout. Question number 7. We have a purely conceptual question here. There are two forces F1 and F2 that look like this as drawn in the diagram over here, and there are 4 options. Each of the options dictate how the resultant will look, and we have to tell which one is correct. So the first thing you should do is on any one of the diagrams, because they have the same F1 and F2, actually try to draw the resultant. So how do you draw a resultant in reality? We take one of the forces and we keep its tail on the arrow of the other force. So like if I take F1 over here, maybe I use a scale or a ruler. This is around 4 centimeters, not to scale, and I take it over here parallelly and I draw it from here. These are vectors, we can move them around. These are supposed to be parallel. And now from the origin I draw one line. So it looks something like this. So this over here should be the resultant. In the diagrams in options A, B, C and D, option A seems like the most correct one because it follows this method. Option B is wrong because it is pointing in the other direction, and options C and D are straight wrong because it is the wrong way of finding the resultant force. So A is the correct option. If you need help with physics or any other subject at igcse's, you can request a session at our website, which is linked in the description. We are a non-profit built by students for students, and everything is completely free. Question number 8. We have been given two cars. The first car is mass 1000 and its speed is 10 meters per second, car P, and the car Q has 500 kgs of mass and its speed is 20 meters per second. Now what we have to do in this question is we have to compare their momentum and their kinetic energy. So let's do it directly. Let's represent it by P. The momentum of car P is the speed multiplied by the mass. Momentum equals mv. So that becomes 1000 multiplied by 10, which in turn becomes 10,000. What are the units? Kg meters per second. What is the momentum for car Q? So momentum seems like same for both of them. Now let's check the kinetic energy. I'll use a calculator and calculate both of them. Okay, so seems like the kinetic energy for car Q is greater. It is 100,000 joules, whereas for car P it's 50,000 joules. So let's check through the options. Option A and D are instantly eliminated because we are only thinking about the cars that have the same options that show the same momentum for both cars. So A is wrong and D is wrong. What about option B? Option B says the kinetic energy is also equal, which is wrong. Option C says the kinetic energy of car P over here 50,000 is less than 100,000, which is absolutely correct. So we have found our correct option. It is option C. Question number 9. We have a car over here which has a mass of 800 kgs. Now the car travels to a hilltop over here. This is a hill and it is traveling to a hilltop. While traveling to the hilltop, the car gains a gravitational potential energy represented by PE of 40,000 joules. Now that happened maybe because the car expended that much of kinetic energy, but that is not what we care about right now. What we care about is the height of this hill. Okay, so there's one very nice formula which is potential energy equals m into g into h. Using this formula over here, m is mass, g is acceleration due to gravity, and h is the height, change in height. Using this formula, we get doing some very basic algebra, we can get that the height of the hill is 5 meters. Therefore, option A is correct. We have a lamp in question number 10 that has a power output of 5 watts. So P equals 5 watts. Now the issue is that the lamp is wasting a power of 1 watt heating the surroundings. So the waste power output I'll represent using W is 1 watt. What we have to tell is what is the efficiency of the lamp. So let's think about what is the effective power output of the lamp, the useful power output, which will be 5 minus 1 because it is actually expending 4 watts of energy to actually light up the room. So I'll write UP, which is useful power output, equals to 5 minus 1 equals 4 watts. Now to find the efficiency, the correct formula is useful power output divided by total power output multiplied by 100. That gives us efficiency in percentage. So we do UP by P Notice that the watts get cancelled and this is just a percentage. It is just a number. Therefore, the option C is correct.